So these are flip notes 2.2 on memory encoding. We're still in unit 2 on cognition. My Bitmoji is going a little crazy trying to input some information there, which is the first part of memory encoding. So let's get to it.
So there's 3 levels of memory in the information processing models. The first is encoding, which is our focus on this section, all about how we get information into our brain. Then how we store that information, including long-term and short-term memory, and then what's maybe the hardest part of memory, and that's retrieval. It is a sequential process, and it goes in that order. The Atkinson-Shiffrin model specifically identifies these 3 stages of memory, which are sensory memory, short-term memory, and long-term memory. The problem with the model, though, is it doesn't really explain how sometimes information skips those first 2 stages, and it'll go straight to long-term memory automatically. And we'll talk about these in a future section, especially things that are traumatic or extremely emotional will go straight to long-term memory. We also can't focus on all the sensory information we receive. We are constantly bombarded with sensory information. So we just select some of that, and then it goes into working memory. And the model doesn't really accurately describe working memory. So working memory is really a newer understanding of short-term memory. The thing about working memory is it's a lot more of a conscious, active process. That it's basically what you're doing right now. It's taking all the incoming auditory and visual information, and then it's combining it with other long-term memories that you have. So it's really very active thinking. There are some disorders that we'll talk about in later chapters that affect working memory, specifically schizophrenia, which causes scattered thoughts, and then Alzheimer's disease, which deteriorates memories over time. So encoding is all about how we encode information. And there's 2 ways. We encode some things with automatic processing and some things with a little more effort. So some things are definitely automatically processed, like locations, your route to school. But if it's new or unusual, then it'll require more information, and that requires extra effort. Some things that we automatically process, space. So if you're reading a textbook, or you're looking at place or a picture, you tend to automatically encode where things are on a picture on a page. We automatically encode time. We kind of take notes of when during the day things happen. You just tend to remember, oh, that happened before lunch, or that happened during 3rd period, or that was more in the evening. We automatically encode time. And frequency, we tend to keep track of how often things happen to us. All of that automatically. Effortful processing, though, are things that are new, that require a little more effort to get them into the memory store, like learning a new concept. And usually, but not always, the more effort given leads to a more durable and accessible memory. So encoding, we can already divide it into effortful and automatic processing. The person we associate with this section is Hermann Ebbinghaus in the late 1800s. And he really studied how we encode memories with rehearsal. Rehearsal is kind of a fancy way of saying studying or repeating things over and over. And he said that effortful learning usually requires rehearsal or conscious repetition, that to learn something, you consciously have to repeat it. And he wanted to know, how much do you have to repeat it? So he studied what he called nonsense syllables. He had to study something that he didn't already know the meaning of. So he would just rehearse these random 3-letter syllables and see how long did he have to rehearse them before he would remember them. And what he found seems fairly obvious to us, but it was what he studied, is that the more times he studied the nonsense syllables on day 1, the fewer repetitions were required to remember them on day 2. So basically, if you study it the first time, the second time when you rehearse them, you don't have to study it as long. And he shows that here with the number of repetitions of the list on day 1 versus day 2. Some different effects that things that affect memory. The spacing effect says that we retain information better when we rehearse it over time versus cramming it all together. So when we space information over days of rehearsal rather than minutes before a quiz, you're much more likely to recall it later. The serial position effect, this has to do with when we're thinking of a list, when your recall is better for the first and last items on a list, but it's poor for the middle items. So we can remember the beginning and the end of a list. We tend not to remember the middle of a list. And then the serial position effect breaks down into two more effects, the primacy effect and the recency effect. Primacy effect says that we remember stuff at the beginning of the list because we've been rehearsing it more. That if we had 20 things and we kept trying to say that list over and over again in our head, it has made it into our memory, into our long-term memory. It's been rehearsed more. Whereas the recency effect, those are things that you just got done saying at the end of your list, so they tend to still be in your short-term memory. We'll practice this one in class. So here we have the number on the list, its position. Was it number 1 or was it up to number 20? And how likely you are to recall them. We recall things at the beginning of the list and the end of the list, and sometimes randomly things in the middle, and we'll talk about what other things you tend to remember. So serial position effect is also sometimes called the primacy recency effect. We encode information in different patterns. We encode by meaning, or rather we say by semantics. We encode iconic memories, another way for saying images or visual memories. We encode by how the information was organized, and we encode by sound, or how things sounded to us acoustically. Which is best? Generally, semantic memories. Once you know what something means, you're going to remember it better. If you're learning a new concept, you're going to remember it once you actually understand the concept, followed by acoustic memories and then visual memories. We also can look at different levels of processing, how deep we process information. At a shallow level of processing, we're really just looking at the structural components. Was it written in capital letters? You could even look at like what font was it in. Intermediate processing is what did the word sound like? This comes from the word phonetics, which is like when you sound something out phonetically. Did the word rhyme with another word? What did it sound like? And then deep processing, again, is semantic encoding, that we remember stuff best when we emphasize what it actually meant. Would this word fit in this sentence because of its semantics or its meaning? And again, even in these three, semantic encoding is the strongest, that we tend not to remember structural encoding as well. But phonemic encoding, we can remember how things sound. And then semantic, because sometimes you'll say, oh, I remember the word, it sounded like this, it started with this letter. But then semantic is what it truly means. Other effects that help us to encode information, the self-reference effect says that we tend to encode and remember things better that refer to ourselves. So if we're looking at a list of adjectives, then adjectives that apply to ourselves would be ones that we're more likely to remember. Oh, she moves, but not that much. Encoding meaning, again, semantics. Once we process the meaning of verbal information and we're able to associate it with what we already know, we have better recognition later on. The encoding by semantics means that we recognize through knowledge, we know details, we can give explanations and examples. So semantic really, really is that deep processing. Visual encoding, or also called iconic encoding, still can be very powerful though. So mental pictures or imagery really help us to remember along with semantic encoding. So for example, I can tell you how bad smoking is for you, but by showing you a smoker's lung versus a healthy lung, that's going to have a lot stronger impact on you. So when we're combining visual and semantic encoding, much more likely to remember things. Other things to remember about encoding, the next in line effect says that we seldom remember things when we're the next in line. So let's say you have to give a speech, then while the person before you is going, you don't remember what they talked about. You're too busy worrying about what you're going to talk about. That's the next in line effect. When you process the information matters. Information minutes before sleep is seldom remembered. In the hour before sleep, though, it's well remembered. And that has to do with giving it time for your brain to process it, to send it from short-term to long-term memory, for your hippocampus to process that information. So if you're studying late at night, it really makes sense to just kind of stop and go do something else for a little while before you go to sleep, rather than literally studying till you fall asleep, because those last things you studied are not going to be recalled later. And then finally, the idea of just trying to play information, taped or recorded information that's played while you're asleep. Your ears may pick up on the sounds, but you're not going to remember that, if only if it were that easy. That would be great. Your motivation to remember also affects how well you encode information. If you know is something super important, you are more likely to record it or to remember it. That doesn't mean remember everything. There are definitely important things that we forget and then we feel really bad later, but less likely to forget. Here's that spacing again. We encode better when we study or practice over time. You shouldn't cram, but cramming is better than nothing. The problem with cramming, or the fancy name for that, is massed practice. You practice all at once, is that you tend not to retain the information as well over time. So when you're comparing retention, even on a short-term scale, between spaced out practice or mass practice, space practice is going to win. You're going to remember it better when you learn it over time. But especially later, you're really going to recall the information that you studied over time better. So no cramming is better than nothing, but spaced out is better. So how can we encode information better so we're more likely to recall it later? Here are some tricks, or rather than calling them tricks, we could call them mnemonic devices. Mnemonic devices are techniques to help new information link to information that you already have, making learning easier. Visual imagery, and we'll talk about each of these other types here, and we'll practice them a little more in class. The peg word system involves having a set of memorized peg words, like 1 for bun, 2 shoe, 3 tree, and then you link the word that you want to memorize with the peg word. That one's easier when we practice it in class, so I'll explain that one a little bit more in class. The method of loci is also called the memory palace, and this is based off of what the ancient Greeks would do when they were trying to memorize long speeches that they had to give, but they couldn't write them down. They just didn't have the means for writing out information back then. Is that they would associate their memories with actual locations. So they would walk around their palace, and in each room of their home, they would memorize a portion of their speech. And then when they had to give the speech, they would visualize themselves in each of those rooms, and then that part of the speech would be recalled. In the picture here, it looks like the person has associated their grocery list with different parts of their house. So it looks like they've got hot dogs in the driveway, cat food by the garage, maybe that's jam or tomatoes on the front door, bananas in the closet. So as they're walking through the grocery store, they're thinking, okay, when I was in my driveway, what was in the driveway? Hot dogs. So they associate it with a location. How we organize the information will also help us encode it better. We can break down complex information into different categories through chunking and hierarchies. In chunking, we break them down into something more familiar. So here we've got this long string of numbers, but if we were to chunk them, you might recognize them a little bit more as years. Here's some more. We've got a bunch of letters, and we could chunk them into some more familiar abbreviations. Acronyms are a type of chunking. With an acronym, we take the first letters of what we've chunked it with and they form a word. So for example, you could memorize the Great Lakes of the United States. They spell the word homes for Huron, Ontario, Michigan, Erie, Superior. Still takes some studying though, because you'll remember that the first letters are HOMES, but you still have to remember the names of the lakes. Or perhaps you've remembered the order of the colors of the rainbow by chunking using Roy G. Biv. Some other acronyms, maybe you've used ones to remember the planets, or maybe PEMDAS in math class. Another way to organize information into something more memorable is with a hierarchy. And then here we break it down into categories and subcategories. So for example, minerals could be broken down into metals and stones. Stones could be broken down to precious or masonry, metals into rare, common alloys. So it's a good way to organize the information. This is one I've used in my other history classes before, where we're trying to break down Christianity into its hierarchy of its different branches. And if we wanted to break down encoding into a hierarchy, so we said encoding can be through automatic or effortful processing. We can encode meaning, which is semantics, imagery, which is iconic, or we can organize it. And when we're organizing them, so we can break down the information into chunks or hierarchies.